remember what numbers you had, so you will have to, you just tell me which ones you think you need, and I will work them out. You have to tell me what they are because I really don't even. 17. 17. All right, so this one is nice piecewise here. 4 minus x. So this one's when x is less than or equal to 2. So I am checking. Determine whether the curve has a tangent at the indicated point. If it does, give its slope. If not, explain why. So I first need to check the continuity at 2, right? The limits from both sides and the function defined need to all be the same thing. So the limit as I come in to 2 from the left is 1/2. The limit as I approach 2 from the right, 4 minus 2 is 2. So it's 1/2 again. So it is continuous, which means I can proceed with the difference quotient. And I need to do it for both sides and make sure the slope matches for both sides, right? Oh, are y'all ready? All right, difference quotient, the limit as h goes to 0 of f of x plus h minus f of x all over h. And since we're looking at a specific value, we can go ahead and just plug that value in here. So I'm going to go from the left and from the right and see if that equals. Thank you. Good morning, Khalil. You have a rough morning? You made it. We're glad you joined us. Started on time this morning. One morning you were not here. We started on time. I'm sorry. They had a lot of questions about the homework. All right, so I'm going to go ahead and plug 1/2 in here. From the left, I am using the first equation, and then from the right, I'm going to use the second equation. Question mark. If you didn't set it up this way, and you did each one separately, that's fine too. All right, this side's 1 over x. This one is 4 minus x over 4, just so I remember. Here we go. So I have 1 over 1/2 plus h. Oh, I see why y'all had trouble with this. It's the fractions, isn't it? Did I do it wrong? That's the point that I'm checking the slope for. That's the one. Oh, never mind, it's 2. I'm sorry. Oh my goodness, I got to get my crap together this morning. I'm sorry, y'all. It's okay, Miss Williams. We all make mistakes. Thank you. Thank you. 2. Sorry. 1/2 is the function value at that point, and that's my limit. Okay. My bad, my bad. Limit as h goes to 0 of 1 over 2 plus h minus 1 over 2 all over h. That's a lot better to work with. 4 minus 2 plus h over 4 minus, if I plug 2 in, I get 1/2 over. Common denominators is what I need. I think I will give this one a 2, and I will give this one a 2 plus h. Does that make sense? So I have the limit as h goes to 0. This is 2 minus all of this, 2 plus h, over 2 times 2 plus h, all over h. Too fast? Too much? Are y'all still? Yep.
Hello.
Yes, that's what I did for that one. It won't always give you a least common denominator, but it will give you a common denominator. You can simplify later. In this case, that was the least common, but how about on the right side? What's your common denominator there? Up top. 4, so I just need to give this one a 2. Limit as h goes to 0 of 4 minus 2 minus h minus 2. Oh. Yep. Well, I distributed that minus. That's why I went ahead and dropped them. All right, let's clean it up a bit. 2 minus 2 cancels. So I have negative h over 2 times 2 plus h all over h. Four minus 2 minus 2. So negative h over 4 over h. Are y'all checking me as we go? I've got negative h over, I'm going to go ahead and distribute this through, 4 plus 2h, and I'm going to multiply by the reciprocal here. Same thing here, I'm going to multiply by the reciprocal. And now I can start working a little magic. I've got 1 over 4 plus 2h. Yep, sorry. And negative 1 over 4. Which doesn't look like the same thing, but if I plug the 0 in for h, which I can now because I'm no longer undefined, so yes, they have the same slope from the left and the right, and that slope is negative 1/4. That was a tough one. Does it make sense though? You okay? All right, what else? 21. Let me mark what I gave y'all. Which ones did y'all have to do? I know you did 17. All right, wait, 14 what? Okay. Okay. Ooh, I gave y'all a lot. That's it. Sorry. Okay, you said which one? 21? 20? 21? All right, 21, y equals 1 over x minus 1. What am I doing? Find the slope of the curve at x equals a. So our slope of the curve is going to be difference quotient, right? So I'm still doing the limit as h goes to 0. This time I'm at x equals a. Okay, so it's f of a plus h minus f of a all over h. Agree or disagree? I just plugged an a in for that x. This is just going to be a whole lot of manipulation is all this is going to be. And then we'll answer the second part of the question. Okay, so the limit as h goes to 0, 1 over a plus h minus 1 minus 1 over a minus 1. Any ideas what I need to do? Yeah, common denominator. What do I need to multiply? Understand this is all one chunk here, right? I can't factor it or anything. If I could factor it, that would be nice and I wouldn't have so much. But this one's going to need an a minus 1. This one's going to need an a plus h minus 1. Did anybody do this one? Is that how you did it? Okay. And you stopped. Okay. Yes, ma'am. Well, it's always around the whole, it'll always be around the whole thing, and then if you can factor it, you'll have those separate parentheses. What do you mean around just the x? Are you talking about where I plugged in? You're talking about where I plug it into the equation? So if something's being done to the x, like if there was a squared here, if there was, so if it did this, then whenever I plugged in this, I'd need to put it in parentheses with a squared. So if there's any operation being done to x, if there's a 3 in front or that x followed something and everything needed to be subtracted, if there's anything being done to the x, then I'll need to put it in parentheses. All right, the limit as h goes to 0. So now I have a minus 1 minus, and I'm going to follow this one in parentheses so I make sure I distribute that negative sign. This is all over a plus h minus 1 times a minus 1. Because that's my common denominator, right? Whatever I give to the top, I have to give to the bottom as well. And everything goes over h. Now the limit as h goes to 0. I'm going to write this out for you so you see what it looks like with the negative distributed. Don't start canceling anything out here because remember to cancel factors out, you can't have these plus or minuses that are not in parentheses yet. But it looks like there's a lot of stuff that's going to start canceling. The A's are going to go away as well as the 1s. Don't need to wait a second? Y'all good? So now the limit as h goes to 0. I have negative h over a plus h minus 1 times a minus 1, and I'm going to go ahead and multiply by this 1 over h here. Save myself a step. Which, of course, cancels. I don't know if I need to take this, well, yeah. Missing that negative sign. Instead of dividing by here, by that h, I went ahead and multiplied by the reciprocal. And all of these are going to end up, in the end, they're going to be multiplied by 1 over h unless you just, because that's our difference quotient from the beginning is divided by h. So now I'm to the point where I can plug 0 in for h. And so I end up with negative 1 over a minus 1, right? Or a squared minus 2a plus 1, however you want to do it. So then it says, so this is the slope of the tan line when x equals a is negative 1 over a squared minus 2a plus 1. So it says describe what happens to the tangent at x equals a as a changes. As a gets bigger, yes, it would get smaller. Because my function, this is, yes. Right, because you're getting bigger on the bottom. So the bigger a gets, right, as I plug in bigger and bigger numbers for a, so I'm doing a squared, even though I'm subtracting 2a, that a squared is going to overpower the 2a. And it's on the bottom of a fraction. So as a gets bigger, the slope is getting smaller. Y'all okay on that one? Very conceptual with the variables. What else? Give me another one. Which one? 25? We'll probably practice with some more of these today. At t equals 2. Find the instantaneous rate of change of the position function in feet at the given time t in seconds. So this is just the difference quotient when x is 2. So we do the limit as h approaches 0 of f of, I'm going to go ahead and put the 2 in here. What would happen if I wanted a general equation for the slope instead of at a point? But I wanted an equation to find any given instantaneous speed. You know what you would do? Anybody? If I left the variable in here, the t in there, and then simplified, I'd have an equation that I could plug any value in and find the instantaneous speed or instantaneous change at that point. Does that make sense? I'm plugging in the beginning just because it's easier to work with, but I could plug in the end is what I'm saying. I could leave it f of t plus h minus f of t. Get an equation and then plug different values in for t to find out. It's just a lot more work, but it does work. All right, here we go. The limit as h goes to 0, 2 plus h plus 1 over 2 plus h minus 2 plus 1 over 2 all over h. Limit as I go to 0 of 3 plus h over 2 plus h minus 3 halves. Boo, another fraction that needs a common denominator. I'm going to give this one a 2, and I'll give this one 3 plus h. 2 plus h, sorry. I need the denominators to be exactly the same. So I'm essentially letting my least common denominator or my common denominator be 2 times 2 plus h, the product of the two denominators. So I gave it what it was missing. 6 plus 2h minus, I'm going to go ahead and combine these as well, 6 plus 2h. And everybody goes over. Wait. Thank you. 2 times 2 plus h. Everybody over h. Yay day. I promise you IROC gets better when we get to the next chapter. All right, so the limit as I go to 0 of 6's cancel, negative h over 2 times 2 plus h, 1 over h. Finally, I can plug that 0 in, which was my goal, to be able to plug 0 in as that limit approaches 0. If I put 0 in here for h, I end up with negative 1 over 4. What were my units? In feet at the given time, t seconds, so negative 1/4 feet per second, because I'm a rate of change. Don't forget your units. That's odd. Wasn't that the same thing we got for the last one? Or one before that? Sure. Which one did you say? 14. Okay. Absolute values are not my favorite to work with. This x equals 1. So difference question again as I go to 0. F of 1 plus h minus f of 1 all over h. So that's the limit as I go to 0. 1 plus h minus 2 minus, if I plug 1 in, I get 1. Is that right? This is negative 1 plus h minus 1 over h. So I guess I need to set up the positive and the negative version of this and see what happens. Do y'all understand what I'm saying? So negative 1 plus h, the absolute value, could be negative 1 plus h or 1 minus h. Right? Because it forces it positive. So even if that was in other words, if I did negative 1 times negative 1 plus h, that's the same thing as negative 1 plus h. Would you agree? Yes or no? Does that make sense? So I could do this either way. If I do it, if I just drop the absolute value signs, I'm not going to be anything I can use. I'm still going to be in undefined territory, right? What do you mean? Well, if you distribute it, but what I'm saying is this forces positive, right? So the absolute value would come and say, oh, well, it's still negative 1 plus h. Because the absolute value would take the negative away. Does that make sense? Absolute values stink. Think about them on a graph. They can be on either side of that vertex, right? And still have that same y value because they're always going to be. So I can change all the signs here also. When you solve an absolute value equation, if you had x plus 2 equals 5, you'd say x plus 2 equals 5, or 2 equals -5, because either one of those would work, right? So this essentially is changing, I can change all the signs on this side, or I can change all the signs on that side. Same thing. I feel like I'm not doing a good job explaining this. And I feel like it's because I really don't like absolute values either. You can change all the signs inside, and that's another solution set. So here, if I change that, I've got the limit as h goes to 0 of 1 minus h minus 1, and now it makes a little more sense because these would cancel. Well, I can do either way with the absolute value to solve. And if I did it, if I just dropped the absolute value, because that's one solution set, -1 plus h minus 1 is going to be h minus 2. And since I'm over h, that still doesn't allow me to sub in. So then I went the other way to see if I could sub in. And I could. Don't sweat that as much. Because -1 and the limit of a constant is the constant. Yes. Did you get the right answer? Did you get the same thing? X plus 2. Mm-hmm. So that's kind of what we did right here, where I said you could do that -1, and it's this. But go ahead, keep going. And that's the way she went through and solved it. It's the same kind of thing. She could have done a better job explaining it to you than I did. Okay. Well, there. What number was this? 14. Yeah. Hey, there you go. This is a calculator problem, so sure. All right. What else? 34. I can't believe nobody's asked about 30. Yeah. Okay, 34. Horizontal tangent. At what point is the tangent to f of x equals 3 minus 4x minus x squared horizontal? So I'm looking for a horizontal tangent. What does that mean to be a horizontal tangent? Slope, straight line across. What does that mean about the slope? What's the slope of a horizontal line? So if I'm talking about a horizontal line, that has a slope of 0. So what I'm going to do is I'm going to do difference quotient. Then I'm going to set it equal to 0, and I'm going to solve it for x. Let me write that down. This is a common question on the exam for some reason. They ask you constantly about a vertical tangent or a horizontal tangent. Vertical tangent being where the slope is what? Undefined. So you want where the bottom's 0. Horizontal tangent is the most common, but that's where your slope is 0. So I want difference quotient. I'm going to set it to 0, and then I'm going to solve for x. That's my limit as h goes to 0. And this one's going to be a little tough, but this is going to give me that general equation that I was talking about a little bit ago, where I'm not plugging in a specific value for x. I'm going to leave x as is and come up with this equation. All right, nothing to it but to do it. The limit as h goes to 0. Remember, it's f of x plus h minus f of x all over h. So notice what I'm plugging into. I'm plugging into this nice, pretty quadratic. Y'all tell me if y'all need a break if we start working too many and we need a break in between. Talking a lot here. I'm sorry. All right, I'm still going to 0. 3 minus 4 times x plus h minus x plus h squared. I hope that answers your question about imprint. I love the O's. So f of x plus h says so, and that might be my fault because I didn't teach you, like, we went through plugging in numbers. We haven't really done a general one. I think we did one in the very beginning. Just keep the x in there. That's okay. What we're going to do is we're going to get a formula at the end, okay? And that formula, I could say, I'll show you what we can do. Let's get through the end of it, then I'll show you. All right, minus f of x, but I'm going to put f of x in parentheses because I'm subtracting everything in f of x. All over h. Preston, this is the way you do all of yours, isn't it? Okay. The limit as h goes to 0. 3 minus, now I'm just bogged down in all this algebra. Minus, I'm going to go and FOIL that out, but I'm subtracting everything that's FOILed there. So x squared plus 2xh plus h squared minus 3 plus 4x plus x squared. You could start crossing out here, but just so you see where everything's coming from, I'm going to distribute that negative sign through so you can see how beautifully things start canceling. This negative here. That's where I FOILed out that x plus h. But because I was subtracting everything there, I had to distribute that negative sign. I'm going to wait here for you to get caught up with me before I start. I thought that was Miss Hutto teaching Friday, but she doesn't have a first block. Y'all hear a woman talking? I don't know. But I keep hearing it. Norad's under me. It's not Nord. All right, let's start marking out. I see a positive 3 and a negative 3. A negative 4x and a positive 4x. A negative x squared and a positive x squared. Is that it? Now, if you see this, you can go ahead and do it. But now look at what's left. I've got this, this, and this. And what do you notice about those three? They all have an h I can take out. I'm lazy. I like to do it all at one time. I can take an h, an h, an h, an h. Because everybody that was left had one to give. So now I am at the limit as I go to 0. Negative 4 minus 2x minus h. Remember, the goal was to get to where I could plug in 0 for x, and now I can. And so the slope here is negative 4 minus 2x. So this is the slope for h. So this is the slope of the tan line. It's not the slope of the tan line at a specific point. It's the slope of the tan line. Now, I could ask you, what's the slope of the tangent line when x is 3? And you could plug in a 3 for x, and you could find that slope. It would give you the same thing had you plugged in 3 in the beginning and worked through. This is just a lot more work, but it gives you a general equation and you can find that slope at any particular point. Yeah. Okay, so that's exactly right. At the beginning we said, read it to you again. What number was this? 34. At what point is the tangent horizontal? So we want to know when does negative 4 minus 2x equal 0? When is the slope of the tan line 0? When x is negative 2. It didn't just ask me what value of x, though. What did it say? At what point? Well, there's the x. A point has two parts, an x and a y. So now I have to go all the way back up to my, I know, and you have to plug it in. Because it has, good job, Greer. Good job. To what? Tell her to what? What are we plugging into? The original equation, f of negative 2. 3 minus 4 times negative 2 minus negative 2 squared. 7. So now answer the question. At what point is the tangent to f of x horizontal? Negative 2, 7. That's the answer to the problem. The answer to the problem is not negative 4 minus 2x. It's not even negative 2. It's negative 2, 7. Y'all okay? Well, yes, Henry, that would work. For this one, that would work, yes. That was very smart. Yeah, yes. We will actually get to that. You're a couple chapters ahead of us, but we will get to the point where we know that slopes of tan lines are always 0 at maxes and mins. Your husband's better yet. Henry said he just found the vertex of the parabola, and that also works because that's, but you're not supposed to know yet. You're ruining all the fun. No, I'm just kidding. All right, anything or what else? I know there's something else. Y'all need a break for a second? You need to let your brain settle a second. Khalil is always willing to take a break. Slope of the curve at x equals a. So I'm doing the difference quotient when x equals a. So the limit as h goes to 0. Oops. Minus f of a all over h. So we have a plus h squared plus 2 minus a squared plus 2 all over h. Start working algebraically with some of this. So FOILed out, that first one is a squared plus 2ah plus h squared plus 2 minus a squared minus 2. Can y'all FOIL in your head now without having to work it all out? Y'all know what I'm doing when I do that. It's a big time saver. Square the ends and then take the 2 and multiply them together. Double in the middle. All right, let's cancel out what can cancel. I've got a squared's gone. 2's gone. Then I also have an h, an h, and an h. So I end up with the limit as h goes to 0 of 2a plus h. I can plug 0 in now. So the slope of the tan, I should always say that. I shouldn't just circle it and be done. The slope of the tangent line is 2a. And what does that mean as x changes, or as a changes, excuse me? That's exactly right. As a increases, the slope increases. The sine of a is the sine of the slope. As a decreases, the slope decreases. 30. 30 is a good one. Everybody always asks you, I need to remember these equations. Most of the time, um, especially in an FRQ situation and in a multiple choice too, they embed these formulas in the question. So they'll say, if the volume of a sphere is pi r 4/3 pi r cubed, then what is the blah 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 blah? And so they'll give those to you. I don't remember. I mean, you do not look like you feel well. You okay? I'm sorry. All right, so with respect to the radius, when the radius is 2, rate of change of the volume. Okay, so I'm going to do difference quotient. Limit as h goes to 0. And I'm going to do, this time it's v, right? So v of 2 plus h minus 2 all over h. Does that confuse y'all? That's the volume with respect to radius instead of function of x. Well, that no, because that won't give you the rate of change. That would just tell you what the volume is. So that'll give you the, I don't know what, cubic inches, but it won't give you the rate that it's changing, if that makes sense. All right. That's okay. This was a hard one. This one was tough. I figured that would be the first one y'all asked me about. Here we go. The limit as h goes to 0 of 4/3 pi 2 plus h cubed minus, I know, 4/3 pi cubed all over h. I'm coming off to the side to cube that one out. So I have 2 plus h cubed. I know 2 plus h squared, that's easy. That's 4 plus 2h, 4 plus 4h plus h squared, but I have to multiply it by another 2 plus h. Well, that's not going to help me get my h out of the bottom. So, double everything and then give everybody an h. I know. H cubed plus 6h squared plus 12h plus 8. Now remember, this is all times 4/3 pi. Yeah. Good. I'm actually going to make this 16 over 3. Y'all check behind my, it is. I was wondering why that wasn't canceling out with this other. That's exactly why. That's 8, that's 8 times 4 is 32. Say that again. No, because these are all multiplying and they're not adding or subtracting. So the one negative in front is sufficient. Okay. Now, I know that I can distribute this through, right? I'm going to go ahead before I distribute this through and say, whenever I distribute this here, it's the same thing as this, right? You agree with that? I'm going to go ahead and mark that one off. And then I'm going to go ahead, because this is being multiplied to all of these, I'm going to go ahead and knock an H off of everybody while I'm here. Are y'all okay there? I essentially factored an H out and canceled it. So it leaves me with the limit. If I do too many things in one step, tell me, because I can write them out if you need them. You get confused. Now I've got 4/3 pi times H. I just really did not want to have to distribute that 4/3 through. Now I can put a 0 in for H, right? And if I put that 0 in for H here and here, I end up with 4/3 pi times 12. Or 48/3 is 16. I just reduced 12/3 to 4. Multiplied through. Now I need my units because units are crucial. Remember, it's rate of change. Okay, so it's the y value, right? Because it's rise over run. So what units is my y or my volume? Because that's my y. What units are my volume in? Inches what? Cubed. Inches cubed per, what is my other variable here? What's my radius? What are the units of my radius? Inches. This is inches cubed per inch. I know that is weird, but that's the rate. It's the y units over the x units, or the dependent over the independent. Okay, so that's my rate of change. Inches cubed per inch. That means for every inch that the radius increases, the volume is increasing 16 pi cubic inches. Does that make sense? Yeah, just say, y'all are just going, yeah, it doesn't make any sense at all, but that's okay. I didn't stress units as much in the beginning last year, and they struggled in the end with understanding what, so I want you to understand, hopefully by starting it early, you'll understand. I can. Not only can I, but I will. Well, you're welcome. You're very welcome. 18. It's a trig function. This one is from 0 to 3 pi over 4, and this one is from 3 pi over 4 to 2 pi. Determine whether the curve has a tangent at the indicated point. Oh, at 3 pi over 4. All right, tell me what you think we do with this one. Test the continuity. So the continuity is going to be my limit, so I need to know, does the limit as x goes to 3 pi over 4 from the left equal the limit as x approaches 3 pi over 4 from the right? And is that equal to f of 3 pi? All right, let's go with left first. We'll test left and right. This one should be okay, but we'll see. All right, left is going to be sine, right? So the sine of 3 pi over 4, is that the same thing as the cosine of 3 pi over 4. Where's 3 pi over 4 on your handy dandy yellow circle? Quadrant 2, right? Quadrant 2 has opposite signs. So even if I don't know the values, if I know where it is at least, I can know that these are never going to equal because one's going to be positive and one's going to be negative. So no, this does not have a tangent at that point because it's not continuous at that point. That was it. Always check for continuity first. It's not continuous. That's it. Did y'all do a lot of work for that one? Yeah. Y'all went through difference quotient and everything on both sides? Sorry. No. Or did you just look at it and go, I just don't even know? What else? I think we've done them all, hadn't we? Pretty much. Well, let me give you a few to practice on. And then we'll review tomorrow. Let's do, you think you can do them now? I hope so. Let's do 22. We did 25. Did we do 27? Let's do 29. That's the area of a circle. Do y'all know the area of a circle? Pi r squared. Pi r squared. Let's do 35 too, because that's a normal line. You'll have a normal line on there. I had 37 and 38 on there, but I think that's it. I think that's good. Some of them take a little while. And 37 and I'm done, I promise.